Our destination is NEC Semiconductors Ireland, based at Ballivor, County Meath.
Nothing in this landscape looks remotely like a large, integrated circuit manufacturing facility.
True, but we thought it wise to divert slightly, to let you see the cultural and historical backdrop into which the NEC plant sits. These ancient burial mounds were built before the Egyptian pyramids. Furthermore, Irish scholars were teaching and learning across Europe more than 1,000 years ago.
And is that quest for knowledge still there today?
It is, and NEC Semiconductors Ireland benefits from that spirit of knowledge and enterprise. Our employees have come through an education system which is the finest in Europe.
Okay, NEC has 39 plants worldwide. What makes NEC Semiconductors Ireland different?
Well, it's the first NEC plant established outside Japan, and furthermore, the sheer range and number of devices, 80 in all, make it different. More of that later.
Has the plant layout changed much since it opened in 1976?
Yes, absolutely. It has been altered and expanded on a phased basis to cater for more complex assembly procedures. Presently, the plant is 7,500 square meters. There is upwards of 30 million Irish punts invested there. It's clear you are talking about a top-class facility.
Before going inside, can you describe an IC for some of us who know nothing about electronics?
An IC consists of an electronic circuit fabricated on a silicon chip the size of a fingernail. That's the chip there with the plastic resin cut away for illustration purposes. Integrated circuits, to give them their full name, are capable of storing 64 pages of news data or performing 100 million additions per second. And with continuous miniaturization, these levels are increasing rapidly.
Where would I see an IC at work?
The program in your washing machine is controlled by an IC. Your VCR won't function without them, and of course they are an integral part of the computer revolution.
So, where does the Irish plant fit into all this? What type of ICs do you make?
In the plant, we make memory devices, up to 4 megabit DRAM and 1 megabit SRAM, and a range of SIM up to 32 megabytes, which are part and parcel of all PCs. We also produce a spread of 4 to 16-bit microcomputers. In addition to all that, we produce large numbers of ASICs, or application-specific devices.
So that adds up to 80 or so different devices.
Correct.
Can you take us through the production process?
Well, we will start in the clean room area, where everybody must be kitted out in sterile work suits. NEC's Irish plant conforms to high-class clean room standards. Entry to the clean room is via the air shower.
So we're inside. Where do we begin?
Start with the silicon wafer. All the individual chips must be inspected and checked in advance of being diced. You are now inside the dicing machine, where a precision saw cuts the wafer so that each chip is separated. The wafer is kept intact by means of a plastic film backing.
What is the next stage?
Each chip is mounted on a lead frame using silver paste as an adhesive.
I assume there are specific lead frames for specific chips.
Correct. What happens next is micro-precision bonding. Remember, each lead frame connection has an appropriate pin terminal. Gold wire is fed through a ceramic capillary tube, which in turn receives a charge sufficient to cut and bond a connection between both. Bear in mind the operation is slowed down and magnified for the benefit of the viewer. In practice, it occurs more than 400 times per minute.
I suppose this again means specific bonding machines for specific devices.
That's right, and we have a line of bonding machines going 7 days a week, 24 hours a day for that purpose.
Why use gold wire?
Well, certainly not for effect. Simply nothing matches gold for malleability and, more important, conductivity.
How long do they remain in this fragile state?
Not long. The next stage is all about encasing these connections in plastic. Remember, we are still in a clean room environment. This time it's the moulding area. A fully automatic process follows, and what emerges are fully protected ICs able to withstand knocks and shocks, not to mention moisture and contaminants.
You're producing these ICs at the rate of 3 million per month. What is the next stage?
3 million, that's correct, and we are only halfway through the process. The devices are permanently marked at another part of the plant.
I see the laser marking machine is computer-based.
You're right, and with these volumes, other marking machines are located nearby. There are several other stages of production, including plating the lead frame, followed by cutting.
I get the picture. Each stage reduces the lead frame to a series of pins.
Quite so. Cutting and forming create the familiar shape of each device. This is all about producing IC packages ranging from 18 to 144 pins in a variety of configuration.
How can you be sure that they are all functioning properly? Do you test sample?
At testing, we check every single unit, using a bank of test machines all feeding into host computers. There is a test head appropriate to each device. That's an 80-pin test head being mounted onto one of our machines.
Testing like this is very thorough.
But it doesn't end there. Further on, our burn-in ovens detect early failures, thus ensuring long-term product reliability.
We must be near the end of the line.
In fact, we are. There is just final inspection where the devices are visually inspected before leaving the plant. This operation runs parallel with a quality assurance sampling procedure elsewhere in the plant.
You talked about SIMs earlier on. Is there a separate facility for that?
SIMs, or single in-line memory modules, are assembled in a self-contained unit within the Beliver operation. Although fully automated, NEC personnel oversee the various stages and carry out visual inspection on an ongoing basis. You are looking at 3 SIMs, which will go on for separation and then final inspection in the one area.
Do you warehouse the finished stock?
No. All devices are shipped directly to customers. It is only an hour's drive from Beliver to Dublin Airport. NEC could not have chosen a better hub because all our customer destinations are served by direct flights.
To go back to quality, it must be fundamental to NEC Ireland's way of thinking.
Quite so. Quality in the widest sense is everything. Our customers take it for granted. The company's mission statement is to achieve world-class manufacturing standards, and we see quality, cost, delivery and technical service as the means to that end. We were the first NEC overseas semiconductors plant to gain ISO 9002 certification.
I see TQM, or Total Quality Management, is part of the company's philosophy. Describe your approach.
TQM is about customer satisfaction, and a practical example of that is our ability to carry out exhaustive testing on our devices. We can even investigate the circuitry down to the silicon level. Devices produced in Japan can even be tested at Beliver in 3 to 5 days. It is worth noting that Beliver is also the European Repair and Service Centre for NEC microcomputer and development systems.
Can you tell me more on your approach to TQM?
Yes. Well, there is employee participation in the form of quality circles. Participation in these groups is voluntary, with a strong involvement from all production areas. Training is provided in order to support and develop these groups.
Tell me about your training.
Training is mostly customized to suit our own purposes. If you look at our total productive maintenance program, it will give you some idea about the type of training provided.
Is there practical training as well?
You mean on-the-job training? Yes. It's extensive throughout the plant. There are even training models. This one explains the fundamentals of pneumatics.
So, TQM is about customers. It's also about employees and training. So what else does it involve?
Well, it's about continuous improvement in areas such as turnaround time, delivery, and yield improvements. We've reduced our yield loss by half in recent years, and we now rank with the best Japanese plants.
We haven't touched on top management structures. Is it hands-on, etc.?
NEC Beliver incorporates the best of both Western and Japanese management style. A top-down and bottom-up dialogue has always been the way.
Perhaps your Managing Director, Mr. Larry Murtagh, might like to summarise for us.
I am privileged to lead a team of bright, highly motivated people, both local and Japanese, who have extensive knowledge of state-of-the-art integrated circuit technology. We're also fortunate to be part of NEC, which is a world leader in electronics and CNC, that is, computers and communications. So, to summarize what you've just seen, we produce over 80 different devices, including memories, microprocessors, and application-specific ICs. We have strong engineering capability and technical expertise to provide customers with fast and effective support. NEC Ireland was the first semiconductor plant outside of Japan to achieve ISO 9002 approval in February 1993. Our quality and delivery performance are on a par with the best Japanese factories, and our aim is worldwide competitiveness through leadership in quality, cost, delivery and technical service, and thereby to provide our customers with excellent products.
Thank you, Larry. I will conclude for all of us at NEC Believer with a single thought. Our task is to be at the forefront of IC technology, and our goal is to be NEC's core assembly plant for Europe.